Okay, so now, now we have a minus in the middle. So we have y squared over 25 minus x squared over 36 is 1. Yeah, the difference between these equations and the whole section we just finished, this section which has hyperbolas, is they have a minus in the middle instead of a plus. I don't know if you look back, all the ones in the last section all had pluses in the middle. So what difference does it make when you have a minus in the middle? The two branches that make the egg shape now turn away from each other. They have a negative relationship. There's my little way to help you remember it. If there's plus in the middle, the two branches have a very positive relationship. They come together and make an egg shape. But if there's a negative in the middle, they've turned away from one another and they have a negative relationship. So two branches go sideways or they can go up and down. They can go either way. They can go up and down branches or right and left branches. So it's not a circle and they're not diagonal. They're either right, left, or up, down. Which one would you think? Look what's in the front. What's in the front? Y. And what is Y usually? Whoops, I struck the wrong one. Not that one. D. Remember, it's usually D. D it is. It's D. D it is. So D it is. Right, left. So this means, or up, down. I keep saying this wrong. Up, down branches. Yeah, so if Y is in the front, it's up, down branches. If X is in the front, it's right, left branches. It's all about who's in the front. Y in the front, up, down branches. Now, I can give you more details about what the 25 means and 36 means when we need it. We don't need it right now. In a couple minutes, I think they'll push us on that. But for now, let me just say, hey, Y in the front, up, down branches. That's all we need on this one. Got the answer. I'm not going to do anything with that 25 and 36 for now. All right. Okay. So x squared over 16 minus y squared over 25 equals 1. So go ahead, figure out which one of those is the right answer. So it's got the minus in the middle, so it's, it's not the egg shape. If there was a plus in the middle, it would be the egg shape, right? It's not this diagonal thing. So it's either B or C. So the branches, who's in the front? X. So that's right, left. It's branches that go away from each other to the right and to the left. It's B. This is easy stuff. See what I mean by this is free points on the final? All right, I'm going to move on. Okay. So it's x squared minus y squared is 36. All right, figure that one out. What's up with that one? So it's the same thing, right? There's just ones understood underneath x and y, but I don't care. Yeah, if they were asking me to do more with it, like find out exactly where those branches are, you're right, Ajane, I would get a 1, and I think we'll do that in a minute. But for now, they're not pushing me real hard, so I'm not going to work harder than they're asking me to. It's not that circle, right? It's not this diagonal thing. It's either branches right, left, or up, down. That's as hard as they're pushing, because it's got a minus in the middle. It's got a minus in the middle, so that's not an ellipse. Those are branches, negative relationship, right? So who's in the front? What is x? X? Where's the x-axis go? Right and the left, huh? Like that. So it's D, like usual. Right? X-axis, right, left. You guys with me on that? X-axis is always right, left. So x in the front, we expect right, left. And that's what we get. Good? So that's all we got to do for these. If you, like I said, if you go higher in math, you get to 2 steps up, trig is next, and then I don't know if you're going the math science road, trigonometry is the next class, math 4A, and after that's pre-calc 4B. We go crazy. I just went crazy this semester teaching 2 pre-calcs, and we went crazy on ellipses and hyperbolas, and we made them find like all kinds of things about it. They kind of hate these things because there's really a whole bunch more stuff to them. But we're just keeping it pretty basic. All right, see if you can figure that one out. We're just getting your feet wet at this point. We're not diving into the deep end yet. We're just getting you used to the water of graphs, of hyperbolas, ellipses, parabolas. So you should get the 1 on the right side. So no, you should grab that y squared and jump it over. You know what I mean? It's kind of not in the right form. See what I mean by that? You got to have the x's and the y's on the same side and a 1 on the right side. Now can you tell easily which one it is? What, x in the front. X in the front, right, left branches, see? Easy stuff. All right, I'm going to move on if you're good. So we have 9x squared minus 4y squared equals 36. Try that one. So what's the first thing we do here? Yeah, get away. Well, really though, they're making these so easy. You could do nothing. I mean, you're right. If we had to do more, if they were going to push us a little bit, then yeah, we should divide by 36. That's true, and get a 1 and all that. But who cares? X squared's in the front. Right, left. There's only 1. I can't believe they're not making more than 1 that goes right, left. D. Next question. They're going to make them that easy. I'm not going to mess around. Right, left. I mean, they'll be way harder on the final, but no, I'm just kidding. They'll be just like this.
I'm not going to teach you.
Yeah. Just, you know.
Get it. Eyeball it.
All right, we good? Good there? So you're right, it's an ellipse. See if it's plus middle. Yeah, let me write that out again. That's a really good question. So yeah, when you have x squared over, anything like 16 plus y squared over 9 is 1. Yeah, that'll be an ellipse, so that'll be the egg shape. And like that, you're totally right. And then when they have the minus in the middle, that makes all the difference in the world. You're right. That's the hyperbola, exactly. And those branches go away from each other. Right, left, because x is in the front on this one. Yeah, exactly. That is the story. And then if there's y squared in the front, if it's y squared over 16 minus x squared over 9, then the branches would be going up and down because the y is in the front. So whoever's in the front, if x is in the front, it's right, left. If y is in the front, it's up, down. For the ellipse, it doesn't matter because it just makes an egg shape. Yeah, that's the general setup on those. Good on that. So that's the general format to look for. So you can put that on your full sheet of notes for the final. And that'll pretty much handle it. Unfortunately, there'll only be like one of these. There'll be one of everything on the final. So these are great. Just half the final. Okay. So if you get that down. So now we're going to change gears here. Something incredibly difficult. No, this isn't hard either. These are easy sections, like I said. So x times y is -3. That's like totally different, isn't it? We don't have x squared or y squared. There's no 1. There's no numbers, no parentheses. I mean, this is like totally different. Notice we have totally changed gears at this point. Okay. Now, you might think I would, if I hadn't done more of these, I would have thought that's linear because it's just x to the first power, y to the first power. Isn't that normally a straight line? But because they're times by each other, because it's x times y, it's not a straight line. If it was x plus y, that'd be a straight line. If you just have x to the first power and y to the first power, and they're not multiplied by each other, that would be linear, we call it, meaning the picture is some kind of a straight line, up or down or whatever. Right? But when they're multiplied, when the x and y are times by each other, do you know what the picture looks like? Well, for a negative, this is what, it's a hyperbola that's been twisted. It's a twisted hyperbola. It's two branches that have gone diagonal. If you have x times y is a positive number, any positive number, then the branches will be in these two quadrants for positive. It'll be in the other two for negative. That's what you want to put in your 3x5 card. Everybody see what I'm saying there? If you have x times y is negative, it's those two quadrants. If you have x times y is positive, it's these two quadrants. It's two diagonal branches. Do y'all see how that's different than the other hyperbola? I mean, the equation's totally different. But also the picture is diagonal instead of straight up and down or right and left. Everybody's seeing that. Right? See how they're diagonal now instead of, you know, like if I had like x squared over whatever, 16, minus y squared over 9 is 1, they'd be straight right and left, wouldn't they? Instead of diagonal. Okay, yeah, so which one is it? Yeah, no, isn't it D? Oh, A, you're right. I'm looking at the wrong one. It's A, it's this one, so it's A. Yeah, because it's a negative, yeah. A it is. Is everybody good with that? So if you just have, it's simply, like we said, we're just getting your feet wet at this point. I just want you to see this level of math. I just want you to see tons of graphs and have general familiarity with a lot of graphs. If you're going higher, then they get more specific about what they do and why they do it and exactly how they do it beyond this. So x times y is 5. So it's a positive number. So what did I say is the picture when it's a positive number over there? It's the first quadrant and the third quadrant diagonal branches. B it is done. See how easy that is? Like taking candy from a baby. Easy? Now, I don't like giving math like it's magic. I'm forced to do that a lot because of the time restraints. You don't have time to explain everything. This one we can pretty quickly see why this is the case. Suppose if we made a little table. Let's see why these weird diagonal branches. Well, let's just do a couple points. I think you'll see it real quick and easy. You can't do 0. If you plug in x is 0, nothing works, right? 0 times nothing is 5, right? There's no way to do that. You can't put in 0. You with me? That, by the way, that's why it doesn't go through the origin. You can't have 0. 0 doesn't work. If I put in 0, 0 times what equals 5? Nothing. But put in a 1, that'll work. So we have x times y equals 5. If I put in 1 for x, what is y? Y's got to be 5. 1 times 5. And now, what else could we do that would be easy? Let's start with x times y is 5 again. And this time, let's put in 5 for x. If I put in 5, what does y have to be? 1. So we've got the points 1, 5, and 5, 1. But not only that, if I put in negative 1 for x, let's go back. If I put in negative 1 times what is 5? You guys with me? Am I losing you? Negative 1 times negative 5. Yeah, my thing's jumping around here. Stay put. There we go. Negative 1 times negative 5. Am I going too quick? And then what if I put in negative 5? Negative 5 times negative 1 would be positive 5. So, okay, so you agree with me? Those are all points on the graph. It's like a light bright, right? Let's put those dots on the graph and connect the dots and see what we've got. So if you go to the graph with that information, okay, where is it? Over 1, up 5. 1, 2, 3, 4, 5. There's a dot. Over 5, up 1. 1, 2, 3, 4, 5, up 1. See how the branch is in that quadrant? Now, back 1, down 5, 3, 4, 5, right there. And back 5, 2, 3, 4, 5, down 1. See how you're getting, now if you did more points, you'd see that they go right around there, and then this one right around here. See how the branches are in those quadrants? That's what makes it true. Points in those quadrants. All right, let's move. Okay, so x times y is a half. X times y is a half. So what do? What do we do about that half? Nothing. Who cares? It's just a positive number for all I care. What did I say? When you have x times y equals positive, I don't care what fraction or what it's just here and here, right? Remember, that's all you got to do. For positive, it's those two quadrants. B, done. Next problem. Right? We don't have to do anything. I just showed you plugging in just to show, hey, it's really true, but we don't got to do anything with that. Oh, well, see, I don't know why they're putting those straight lines in there. That's kind of weird. But it looks like it's just branches that go up down to me. I don't know why those other